Good day, sir. My name is Habila Bulus. I am one of your students taking the machine learning course. This is my first paper review out of the two that we're supposed to do, and I shall be reviewing the paper Machine Learning for Weather Prediction and Forecasting for Local Weather Stations Using IoT. This paper was published in the journal IRJET in the year 2020 precisely. Because of the very important applications of weather forecasting that we've got in sectors of our economy, such as the aviation, agriculture, and even maybe smart cities and smart university campuses, weather forecasting has become a very important field of endeavor in which a lot of improvements have been sought recently. So, and because of that, the researchers try to apply the weather for the machine learning techniques to these particular important applications of weather forecasting. And because they saw that the traditional weather forecasting mostly provided generalized regional predictions, mostly unreliable for precision local applications. Or even though they give you precise, you know, forecastings, it's mostly a very generalized one, such that it's mostly maybe for an entire country or a region, not really applicable to a very localized space. So this particular research was intended to address that problem, or to pave way for more researches in that in this particular field of application. The aim of the research is to develop a local weather forecasting system with remote access. So it's going to focus on a particular local area, but accessing the forecast, of course, can be remote. That is, anywhere in the world, you should be able to access the results of the forecast. And the objectives that they follow to achieve this aim are to use sensors to collect environmental data, implement the IoT functionality to transmit the data to cloud server, read data from cloud and feed it into a machine learning model for predictions, then display the result anywhere they wish to check it. This is their methodology for this particular research. The sensor array refers to the so many sensors that is being, you know, kept kept So these particular sensors are the ones that we use to collect data from our environment, data such as temperature, weather, and others, and so many of the other weather variables. So these sensors are the analog readers of this particular node MCU microcontroller collects this information from the sensors, then give them some little pre-processing and send them to the cloud, open source cloud platform, that is ThinkSpeak, where from there these data are imported into the machine learning model in the form of a comma separated files, and these machine learning models work on them to predict the future, and the results are now still sent back to the server for viewing in remote areas. The machine learning technique applied to this particular research is the ARIMA, whereby there's at the initial stage, it is tested for this test called stationary testing is done on it to determine how um, how linear is the difference between the present, how linear the difference in the readings are, and then the difference in and log transformation is also done on it to in order to sort of scale the readings for any inconsistency and some shootouts or shoot ups in the readings, then the ACF and the PACF for parameter tuning. This shows the machine learning flowchart from the start of it. The CSV file is important, and then the machine learning model is implemented. Then, of course, the results are displayed. The result of the research shows a 96.5% accuracy. They were able to forecast temperature, humidity, and pressure, and the forecasting was also achieved in real time. In real time, The major strength of this study is the realization of a practical IoT machine learning integration, and also they have been able to achieve a focus on localized microclimate monitoring, which means the intended of aim, which was to design, or which was to design a system that is capable of forecasting weather data for a particular specific local area. They were able to achieve it. So apart from the limitations, which were the fact that um, they were not able to apart from the limitations, we also have gaps in the research, which is absence of deep learning approaches. They did not discuss how they model the seasonality differences in their data handling, and they did not also report how they calibrated their sensors so as to know whether this affected their readings or this affected the accuracy of the result or not. And they did not also evaluate how this research could be scaled into a much more larger system. In order to improve upon this, I propose that a neural network model, model such as the LSTM or the GRU is implemented, and also there should be a comparative model evaluation between the ARIMA and this neural network models to see which one gives us much better performance. Then also we also need to improve on the amount of data that we train the system on, because longer training data set will enable us capture more events to enable us have more information about the weather system. Then there should also be a rigorous performance metrics evaluation of the result. So in overall, the research has been able to help us provide a working IoT machine learning techniques, and this will go a long way in helping other researchers improve on it and apply machine learning techniques to weather forecasting. Thank you.